This is my Forces Reassessment. I chose question 95 in chapter 2. A 2-pound-kilogram ball tied to a string fixed to the ceiling is pulled to one side by a force F. Just before the ball is released and allowed to swing back and forth, how large is the force that is holding the ball in position, and what is the tension in the string? So as you can see, drew a force body diagram with tension going here, force going here, and mass times gravity going here. So I drew my axes with force being on the x-axis and mg being on the y-axis. So tension has an x and y component. So come over here, the summation of the forces is equal to 0 because it would be in equilibrium because it's not moving. So the summation of the forces in the x direction is equal to F minus t sine theta is equal to 0. And then summation of the force in the y direction is mg minus t cosine theta is equal to 0. And if you add t sine and t cosine theta to each side, you get t sine theta is equal to F, t cosine theta is equal to mg. Now, you can divide these by each other, and you get t sine theta divided by t cosine theta is equal to F over mg. And once you divide sine by cosine, it equals tangent. And you have F times mg here. You multiply mg by both sides, get mg over here. So then you have F is equal to tangent theta times mg. And so once you have this, you plug in what is given. The angle was 60 degrees. Tangent of 60 degrees times the mass, which was 2 kilograms, is equal to gravity, which is 9.8 meters per second squared. And once you do the calculations there, you get the force of 34 newtons. Now, we need to solve for the tension and the string. And if you come up here, t sine theta is equal to F and t cosine theta is equal to mg. You can go either one, F of sine theta, or t is equal to F divided by sine theta, or t is equal to mg divided by cosine theta. Either one should work, and they should give you the same answer if you did everything right. And I just chose the first one, t equals F over sine theta. T is equal to 34 divided by sine of 60 degrees, which is equal to 39.2 newtons. So the tension is 39.2 newtons.